Once we have a map like this, we can represent data about each country using color to create a Choropleth map. We'll discuss the World Bank GDP Dataset, Gross Domestic Product, hosting data in GitHub Gist, command line git usage, String.substring, handling missing data, Promise.all, joining two datasets, the JavaScript Map data structure, D3.scale quantile, and D3 scale chromatic. I'd like to use this opportunity to explore the world around us and figure out how to compare the relative quality of life or living standards across the world by country. Gross domestic product is like a metric that sort of reflects this. However, GDP per capita, meaning per person, meaning it's normalized by the population of each country, at purchasing power parity may be more useful when comparing living standards between nations. This is the value of all final goods and services produced within an economy in a given year, divided by the population. And check it out, there's already a Choropleth map in Wikipedia about this topic. I think we can do even better than this. I mean, check out this color scheme. It's kind of wacky. Like, look at this. This yellow is so bright. And this color scheme actually goes from dark to light in the middle to dark again. So it's not perceptually linear at all. I think we can do better. The first thing we need to do is get this data. Apparently, these calculations are prepared by the IMF, International Monetary Fund, and the World Bank. So let's see if we can find the data from one of those two sources. Or actually, if we just scroll down, it's all right here. But ideally, our data would have the same identifiers for countries that we have in our GeoJSON. Yeah, let's work from the coding angle for a bit here. I'm going to fork this one and call it Choropleth Map. There we go. I would like to see the identifiers for all the countries that we have access to. So I'll just add a console.log data. And we can see here, first it's undefined, then it's loading, then it is this feature collection with features, each of which has properties A3 and name. This A3 looks like a reliable identifier, probably more reliable than the country name, which we see in the Wikipedia data. Let's take a look at the upstream data from the World Bank. Hey, check this out. They actually have their own little embedded data viz tool with a map option. And there's another Choropleth of the same data. This is another really cool technique, which is called sparklines. Little miniature line charts inside of a list or a table view. But anyway, it looks like there is a CSV download. Here it comes. We've got a zip file with a CSV. Let's take a look at it. All right, this has country code, these 3-letter codes. Fantastic. But it doesn't seem to have actually numbers. That's lame. Oh, that's just the metadata file. Here's the other file, which is a little bit bigger at 193 kilobytes. Here we go. We've got country name, country code, and then numbers for many years, actually, up until 2021. Okay, this looks like usable data, although it is improperly formatted CSV. It's got these 4 lines that are not valid CSV, but that's all right. We can work around that. All right, here's what I'm going to do from here. Instead of putting this directly into VizHub, I'm going to put this up into GitHub Gist. GitHub Gist is a product by GitHub that lets you store sort of miniature Git repositories. And then these files are statically hosted, so you can load them in to any page. So the plan is to put these files from this zip file into a GitHub Gist and then load it into our viz in VizHub. So to name this gist, I'm going to copy this text and I'll say World Bank Dataset, and I'll paste that metric. And then we can create a public gist. Oh, contents can't be empty. All right, let's create the readme.md. And I'll say this dataset was downloaded from, then I'll make a link in Markdown, World Bank, the name of the dataset, and then some parentheses. And then in those parentheses, I'm going to drop this link. Okay, create public gist. Now I want to add these files to it. And because I already have these files and I know how to use Git, I think I'll just use Git. This is a pretty straightforward way. So I'll click clone with SSH, copy this URL, open up a terminal, git clone that URL, cd 49 blah blah blah, and then I'll say nautilus dot to open up the file browser, and now I can say extract to this folder. Now these 3 CSV files are here, and we can see them in the terminal. And then we can do our git workflow to check, okay, what's changed? These new files have been added, and then git add dot. Now they've been staged to commit. Git commit -m for the message, add data files, and then git push. And now it's been pushed up to that gist. And if we refresh this page, there's our data file. And to load this into our viz, we can click on this raw button, copy the URL, and then use this in our code. We already have this constant world atlas URL, so I'll make another one, data URL, and then I'll paste that URL there. Now let's think about what we want to have happen here. We can't render the visualization until after both of these have loaded. And we are already using this unidirectional data flow pattern with a single field called data. There are a few different ways we could go about this. One way would be to copy paste all of this logic and do the same thing for a different field in our state. That would work just fine. But then in the downstream code, we would need to check if both data sets are loaded. Another way to do it would be to fetch these two things in parallel using a construct called Promise.all, and then set our data field to be an object that contains both data sets. I think I'll do it that way. So we'll have to refactor this code a little bit. Setting the state is what we'll do last. So I'm going to pull that out. And this logic is pretty self-contained. It fetches the topo.json data. In order to work with Promise.all, we should actually return topo.json.feature, and this can be cleaned up using implicit return like this. Now this is not valid for the time being, so I'll just comment that out. And then I'll set up the logic that will fetch our World Bank dataset. I'll start by just copy pasting that other one, but now we want to fetch data URL. And instead of response.json, we want response.text because it's CSV. And we will not be using topo.json here. And I'll call this text CSV string. Now let's just see if this loaded at all with console.log CSV string. Okay, it loaded. The next step is to parse this CSV, which is not actually valid CSV because it has a couple of lines that are not quite CSV. CSV should start with the header row, so the task before us right now is to remove this other stuff. One way to do it would be to split by new lines and then just remove a certain number of lines. That would require a bunch of computation to split them and then join it and then pass it into the D3 CSV parsing. And since we know this will be relatively constant, another way we could do it is just to grab characters, grab a fixed number of characters. That would be computationally less expensive. But it would also be brittle in case the length of this changes at some point, but I doubt that would happen, so I think I'll go with that option. I'm pretty sure substring is the operator we can use for that. If we Google MDN substring, we can see how to use it. For example, if our string is Mozilla and we call substring of 2, it will return Zilla. So we want to do the same and just pass it a certain number that will remove all the text before the header row of our CSV. One way to figure out what that number is to copy this text and then make a string and then paste it in there and say .length, and that is 82. So let's try console.log csv string.substring of 82. I think that worked, but it's hard to tell. There might be like an extra new line there. Let me just try 83. Yeah, there we go. And just to really make sure I'm correct, if I try 84, it should get rid of that little quote. It does not. What about 85? What is going on here? Do we have a bunch of spaces or something? What about 95? Okay, that got a bunch of our text. I just have to figure out what this number is. Okay, 87 got rid of the first quote. So we know that our magic number is 86. So we can assign that to a variable called valid CSV. And we need to introduce these curly braces if we want to do that. And now we can pass this into CSV parse, which we are already importing from D3. And so let's console.log that and see if it worked. All right, there it is. 266 rows. Each row has values for all of these various years. But for our purposes right now, for this Choropleth task, all we want is 2021 and the country code. So let me create a derived dataset that I'll call data, and we can map over each of these rows and construct a brand new object with, I'll call it GDP equal to D at 2021, and then country as D at country code, and then if we console.log data, we get GDP and country. Now this GDP really should be parsed from a string to a number, so I'm going to add unary plus right here. And now we have our data. There's a 0 though, that doesn't quite look right. There's another 0. Oh no. What's going on here? We don't want an unreliable map. What if I look at 2020? This also has zeros. Well, I don't think the value is actually 0. See, if we look at the spreadsheet, the value is actually just empty. So we should account for that. This is the whole idea of handling missing data. And if you don't handle missing data, your visualizations could end up being misleading. For example, if we let that 0 slip through, it'll show the value as 0, which is not right. This is a good use case for a sentinel value. And we can set that up like this. If that value is the empty string, we can put the empty string as the value for GDP. Otherwise, parse that number. And there it is. It shows up as an empty string. But to be even more explicit, I think I'll use null here, so the downstream code can check to see if it's null. And if it's null, we know that the data is missing, and we could represent that in an intentional way. Okay, now that we've solved the problem of fetching this data and parsing it, let's solve the other problem of fetching these both at the same time and then waiting for both of them to complete, and then only after both of them have finished loading, then we bring back this logic to set the state of our data field. Firstly, this last promise should actually return this data so that we can use it. And then we can use this construct called Promise.all. Promise.all takes an iterable, or an array, of promises as input and returns a single promise. This returned promise fulfills when all of the inputs promises fulfill. This is how you can execute multiple asynchronous tasks in parallel and wait for them all to finish. And we can use it like this. Promise.all, and I'll pass an array where this entire block is the first element and this entire block is the second element. Now what this will do is load both of these things in parallel, and then after they're all finished loading, this outer promise will resolve. So on the outside we can say .then, passing a function, and the argument to this function is an array of all of the resolved values. So we can use destructuring to call the first one countries, that'll be the GeoJSON, and the second one, I think I'll just call it data. Now we can bring back this logic and say set state, setting a field, and I'm thinking maybe we can call it something other than data, maybe dataset or all data. And this can be defined as an object that has countries and data. And I have renamed this state field from data to all data. So I need to update some other code to use all data right there, and right there, and there, and there, and there, and there, and here as well. Now, when we say console.log all data, it transitions from undefined to loading to this object that has countries and data. All right, sweet. Now, the downstream code breaks because we changed the structure of what we're passing it. When we call map, that map should actually destructure all data here, and that can be further destructured into countries and data like this. Now in all this code below, we were using the term data to refer to what is now called countries. So I'm going to go through and update that. Oh, it's just that one place, countries.features. Now we should have the map back, and we do. All right, sweet. Okay, now we're getting into the real core of making a Choropleth map, which is mapping these features to that other data set that we loaded in. Ultimately, we're going to want to set the fill attribute to be something like color scale of color value of D, and this should be a function. But let's take this one step at a time. Let's first just console.log D and try to figure out how we can get from here to that other data set that we loaded in. All right, console.log D yields this object that has properties, one of which is A3. Previously, we had a color value function that would just retrieve a certain value from the row object. I think I'd like to use this concept of color value as an accessor function, but in our case, it will be a bit more complex because it's going to first access this property and then use this value to look up the corresponding value from the other data set. So let me go ahead and introduce a color value function. Const color value equals a function of the feature. And let's start by saying return feature. Next, we want to drill down into feature.properties.a3. This isolates all of those country codes. But now that I think it through a little bit, color value should actually be passed in as a configuration option on the map. And that should take as input one row from our original data set. So I think I'll rename this other function color value for feature, or maybe feature color value. And color value from the outside should be configured to be a function that takes as input one row from that GDP dataset, and it should return d.gdp. Okay, color value returns d.gdp, and now we want to get from the country code to the row in data. One possible way to do this would be to use data.find, which will loop through every element of the data array, checking to see if it's equal. But that's algorithmically not good because it would have a higher asymptotic complexity than, say, a lookup table. If we use data.find, it would loop through the entire data array for each element of the countries array. These are probably about the same size. So that would be big O of n squared. So to reduce the complexity, we can build up a lookup table. I'll call it A3 to row. And we can use the map data structure that's built into JavaScript. A JavaScript map holds key value pairs. It's essentially a hash table. So you can set these key value pairs, and then you can use get to look up the value for a given key. Assuming this A3 to row is populated, where keys are country codes and values are rows from the original data array, we should be able to say A3 to row dot get and pass in the country code. But how do we populate this map? Well, one way to do it is to just iterate through the data array, and for each row call A3 to row dot set d dot country is the key, and then d, the row itself, could be the value. I'm not sure if country is the actual name. Let me just double check. Console.log data. Yeah, it is. Oh, you know what? I did rename this function, but I don't think I updated the calling code. Yeah, there we go. Okay, this is working. We have accomplished the fundamental join that we needed to do to look up the rows based on the country codes from the map geometry data. Now all we need to do is isolate the GDP value using color value, which was configured. So we want to actually call color value of this thing here, which I'm actually going to call it D so we don't end up with a super long line. Okay, now feature to color value takes as input a feature, isolates the ID, looks up that row, and then uses the color value accessor function to get at that row value. Now we have an error. Cannot read properties of undefined. I'm pretty sure what's happening here is there's a country code in the topo.json that does not have a corresponding entry in the GDP dataset. This abstraction is sort of breaking down. Ideally, the logic that colors the map would have access to D before it gets passed into color value so that it can check if it's undefined, and if it's undefined, it could use a style to show the missing data. So I think I'll remove this function and bring this logic down into our fill attribute calculation. This gives us an opportunity to say, okay, is D defined? If so, then try to use color value. Otherwise, use maybe something called missing data color or missing data fill. Oh, I made a mistake. Identifier D has already been declared. Right. This D here should actually be feature because it's coming from the map data. Okay, now missing data fill is not defined. That could be a configurable option for the map component, but I could also give it a default of maybe black. Okay, now we can refine this logic. It's not quite right because actually, if we're going to return something that's going to be set to the fill, this should be the color scale of the color value of D. But if D is undefined, we should not even attempt to pass the value into the color scale because we know that it's missing. So I think all this logic is correct now. Now all we need to do is define the color scale. And I think I'll do that right here. Color scale is, let's just return like blue for now, because this will actually give us our first visualization that shows which countries have missing data. The ones that are black have missing data. Okay, now we need to actually come up with a reasonable color scale. If we take a look at D3 scale, it has a number of options. Now, when it comes to choropleth maps, I like to start by using quantiles. D3.scale_quantile will compute the quantiles by sorting the domain, and then it's treated as a population of discrete values, which I guess is a stats thing. Yeah, quantiles of a population. It's a lot of mumbo jumbo, but the way I understand it is it figures out bins, as in intervals of minimum and maximum values, where the number of things that fall into each bin is roughly the same. So let's try this. I'll first import scale quantile from D3, and then instantiate color scale to be scale quantile. The domain will be, well, we want to get all the color values out of data. So that should be data.map color value. And then for the range, I think we can pass an array of colors. So let's just try like red, green, and blue. Okay, that worked. That worked. All right, it's a horrible data viz, but I just want to point out that the effect of quantile as a scale is that all of the colors you choose will have a roughly equal chance of being shown. This is why quantile works pretty well. Like there's roughly an equivalent number of red, green, and blue. And if we add one more, the effect is that they will be sort of evenly distributed. So now what we want to do is actually use a reasonable looking set of colors. For colors, D3 scale chromatic is where it's at. We've got categorical schemes, diverging schemes, sequential single hue schemes, and sequential multi-hue schemes. I like these because they are perceptually linear, meaning your eye perceives them as going from one place to another based on the luminance, which is not at all true for this map that we saw in Wikipedia. Though we can try any of these. Now, for each of these, there is an interpolator version, which is the continuous variant, but then there is a scheme at this number k, and k is an integer. That integer corresponds to the number of data classes. So if it's 4, there are 4 different colors, and if there's 6, there's 6 different ones. And those various schemes in D3 scale chromatic are, I believe, derived from Color Brewer, which is a really nice tool to use to get a feel for how these things will look on maps. So let's try this one. We first import it from D3 and then use it to set the range of the scale. So I'll use maybe the one with 5 colors, or maybe 9. And now we can actually see something about the data. This is mapping lower values to lighter colors and higher values to darker colors. I kind of want to flip that. And we can do that by just calling .reverse on this array. Okay, this is looking fairly decent, although it's hard to tell the difference between black and a dark shade of blue. And also you can't really see the borders between the lighter countries. Let's try making the missing data fill gray. Okay, that definitely stands out a bit more. But why are some places still black? You know, this logic actually only checks to see if, for a given country code, there is no row at all in the data. It does not actually check for our sentinel value that we set up earlier, which is null. That means we should expand this section to be a little bit more complex. So if the row exists and color value of D is not null, then we should use this color scale. So actually, let me do it like this. If D exists and color value of D is not equal null. There we go. That works. This works, by the way, because the and operator, the Boolean and operator, it will short circuit if the first condition is not met. So if D is not defined, it will not even try to access color value and evaluate this. All right, now I just want to work on those borders. On our country paths, what if we make the stroke gray instead of white? Or maybe light gray. Or maybe let's tweak it in detail. All right, that looks fairly decent. We can see the borders of the light color countries, and we can also see the borders of the dark color countries. The contrast is poor in the middle, but maybe that's okay. All right, that's how you can make a Choropleth map with D3. It's missing a color legend, which is critical, so that would be the next thing to do. But this is quite an accomplishment. Let me do a quick review of all the changes we've made. We are using scale quantile and this color scheme from D3 to construct the color scale, which maps over the color value from data, which is from our CSV file, and it uses this color scheme with 9 different shades, and we call .reverse to flip it around. In order to actually get that color from the feature from our GeoJSON, we need to look up, based on that ID, the country code, the 3-letter country code, we need to look up the original row from that GDP dataset. And we do that using a3to-row.get, passing in the country code. a3to-row is a JavaScript map that is populated in this for loop by, for each row of the dataset, we set the value at the key d.country, which is that 3-letter country code, and the value is d.row. Once we've got that, we figure out if it is valid by checking, okay, does that even exist? And it would not exist if we pass in an ID that was not present in the original dataset. And also we check, is the color value equal to null, which is a sentinel value that we set up to represent that there is no data for that particular row. So if it's all valid, then we call color scale of color value of D. Otherwise, we use missing data fill. Now, data and countries comes from all data, which is passed in here, along with color value and missing data fill, which has a default value of gray. In viz.js, if the data is loaded, then we use svg.call and we pass in all data and color value configured here to be an accessor function that takes as input one row of the data and returns the GDP value. Now, all data could be undefined, loading, or, oh, I gotta update this, an object containing countries and data. And that is accomplished by using Promise.all, which will do these two asynchronous things in parallel, meaning at the same time. It fetches the World Atlas data for the shapes, and it also fetches and parses the GDP dataset. We remove the invalid part of the CSV, and then we pass the remaining valid CSV data into csv.parse. And then we map over each row, isolating just the things that we want, and also introducing null as a sentinel value to mean missing data if the row has an empty cell. So that's it. That's how you make a choropleth map.